estimated that its sales are growing continuously. Growing is the rate of change. That's why the function given to us is the derivative. So growing continuously at the rate given by. Find the accumulated sales for the first 5 days. Part A. Find the accumulated sales from the beginning of the second day through the 5th day. We don't have to do both. Whatever you want, we can choose. We can read others, or we can stay with this one. Page 6. Is this okay? 63.
Yes, it's good.
Okay, so S prime of t equals 20e to t. So S prime, of course, is dollars per day because it's a rate of change. And then obviously t is measured in days. I put a notes in there. Find the accumulated sales for the first 5 days. Okay, so that would be nothing else but the integral, first 5 days, from 0 to 5, from 20 e to t dt. Remember, the symbol requires dt. Why dt? Because the function has t in it. Otherwise, if it had x, I would have written dx. 20 stays outside, waiting patiently. Which function prime is e to t?
Is it et squared over 2?
Careful. E to 2t would have been e to 2t divided by 2.
Isn't it just et?
E to t. Very good. So then we have 20 stays outside. I plug in 5. E to the 5th minus e to 0, which is 1. Good. So I have no idea what 20 times e to the 5th is. And minus 1. Okay, 2948.26. Very good. How will you determine the accumulated sales from the beginning of the second day through the 5th day? How are we going to determine that?
Is it the definite integral from 2 to 5?
That's it. So in part B, the integral from 2 to 5 from 20e to t dt. We don't have to determine the antiderivative again because we already have it. It's already here. So we have 20e to t from 2 to 5. So this will be 20. Keep the constant outside. It's a factor. E to the 5th minus e to the 2nd. And that's all we need to calculate. Any questions on this so far? Any questions? So what does the integral do? It's the integral from the derivative of the sales gives us the total sales. Okay? So that's the beauty of the integral. You can say that's the area under the graph. Yes, it is. Yes, it is. As long as it's a positive function, of course. Every time we calculate definite integrals, we always have to check whether this function is continuous on this. Yes, it is continuous. This function is continuous everywhere. Okay, so now let's determine this number. Remember, we always check. So we have 20. I'm just going to copy all this and just replace this by e to the 2nd power. So 2820.48. What is this? Total sales between the 2nd and the 5th. because we integrated the derivative function, the rate of change. Okay. In our next section, we have some properties to look at, which I think that they're quite easy to understand. So in 4.4, properties of definite integrals. Okay, so here is one, a simple one. The integral from a to a from f of x dx. So of course, all these functions are continuous functions on the given interval. What do you think this equals to? Notice that this is like 3 to 3, 4 to 4. What do you think the answer would be?
A.
So before you say anything, maybe it's better to picture something here. So here's the function. Here is A, and here is B. This is the area that is represented by the integral from a to b from f of x dx. This one is this. The integral from a to a from f of x dx. What do you think that will equal to?
Is it 1?
But is there any length? Because the area has to be base times height. I have a height, but do I have a width? What is the width between 3 and 3? What is the width between 4 and 4?
Is it
0?
Yes. The area is 0 because there is no width. There is a height, but there is no width. Good. That's one property. The second property, the integral from a to b from f of x dx, is basically the same with the opposite of the integral from b to a from f of x dx. So if I reverse the limits of integration, that equals the same thing, but with minus in front. Okay, here is another one for you. So here's the function f of x. And let's say I have a, I have b, I have c. So the area from a to c from f of x dx, can we write it in a different way? What do you think? Is there a way of rewriting this in a different way?
Would it be from A to B plus B to C?
A to b, b to c from f of x dx. Perfect. Can I insert another one? Yes, as many as you want. So this only proves that the area between a and b for a continuous function, of course, from a to c can be split in any pieces and going backwards. So if I have the area from a to b and the area from b to c, I can write the whole thing as the area from a to c of f of x dx, as long as there is no gap, of course. Okay. Average value of a function, on an interval. Remember a long time ago at the beginning of the class, I was saying, oh, we have the average value of a function between 2 points. We have the we have the rate of change. We have the instantaneous rate of change. We have all sorts. And this is the one that I said you have to wait till, for the average value on an interval, you have to wait till chapter 4. Okay, so if we have a function and we have an interval a comma b, f average is 1 over b minus a times the integral from a to b from f of x dx. So that's a formula that we have to use for whenever we are asked to find the average value of a function on a given interval. And it has to be continuous, always continuous function. Okay, that's basically it, and let's look at applications. So page, which page, page 425. Perfect. Let's start with the first set. Find the area under the graph over blah, blah, blah. So far, 1 through 6. So let's choose. Can I choose 5? Is it my turn to choose or not yet?
We can do 5.
Okay, let's do 5 then. I'm going to copy it. So this is 5 on page 425. So f of x equals negative x minus 1 for less than negative 1, and negative x squared plus 4x plus 5 for greater than or equal to negative 1. Perfect. Perfect. So, oh, no, it's not perfect. So we're asked to find the area under the graph over negative 6 to 4. Now it is. So here's what we notice. There is a negative 1 somewhere in here. Is negative 1 between these two? Yes, it is. So basically, we are looking at two intervals, negative 6 to negative 1, and the interval negative 1 to 4. Negative 6 to negative 1, negative 1 to 4. Because this piece is one function and this piece is a different function. So how will I calculate the area, which is the integral from negative 6 to 4 from f of x dx in this particular situation? Give it a shot. Anything? Anyone?
Would we do the definite integral of negative 1 to negative 6 plus the definite integral of 4 to negative 1? Or yeah.
They have to be in ascending order. Very good. And now what do I write here and here? You have to be very careful. What I write here, and of course dx. And what do I write here? And of course dx.
The first one would be negative x minus 1,
That's it.
and then the second would be the second function.
Of course. Negative x squared plus 4x plus 5. I'm going to write it again. No one can see what it's in there. You don't have to write it again. So this is the integral from negative 6 to negative 1. Why? Because this is less than negative 1. So this is where negative 6 to negative 1 is. And this is greater than negative 1, which means the interval from negative 1 to 4. Okay. So negative x minus 1 dx plus the integral from negative 1 to 4 from negative x squared plus 4x plus 1 dx. Perfect. Is this clear to everyone before we calculate this? Okay then, so.
Excuse me?
Yes?
I think you miswrote the end of negative 1 to 4. Isn't it negative x squared plus 4x plus 5?
I do that a lot. Thank you. Thank you. My apologies. Sorry.
No problem.
Yes, it was 5 and I wrote 1. Thank you. Good. So, which function prime is negative x?
Is it x squared over 2?
Right, very good.
And then
Minus.
minus x
Good. From -6 to -1. Plus.
negative x cubed over 3 plus 4, and then x squared over 2, and then plus 5x.
Brilliant. Thank you very much. Good. So now this is cumbersome. From this moment on, it's just arithmetic, right? Careful, careful, careful. I have to plug in -1. -1 squared will be 1. 1 over 2 is 1/2 with minus in front. When I plug in -1, I get +1. Be very careful now. Write minus and open parentheses. I plug in -6 and it's 36 over 2, which is 18. -18. I plug in -6 and I get +6. Now I'm here, plus. I plug in 4, -64 over 3, plus 16 times 2, 32, plus 20. Don't forget, put minus, open parentheses, because you may forget to distribute. -1 cubed is -1 with minus in front is 1, so 1/3. -1 is 1 times 2 is +2, and this is -5. So one more time, I plugged in -1 and then minus when I plugged in -6, plus I plugged in 4, minus when I plugged in -1. I know this is a mess, but I have to finish it. So -1/2 plus 1, that's 1/2. -18 plus 6, -12 with minus in front. -64 thirds plus 52. Minus 1/3, and this is -3 with minus in front. Okay. 12. So this is, what is it? 64, 67. -64 minus 1, -65 over 3, and plus 1/2. So least common denominator is 6. This needs a 6, this needs a 2, and this needs a 3. So 6 times 67 minus 120, 130, and plus 3. So I'm going to share my screen and get this number. So 6 times 67 minus 130 plus 3. What is that? 275 divided by 6. Okay, so here's how I check my 275 divided by 6. Let me see what it is. Okay, some gibberish there. Okay, good. So then math and number 9. Be very careful how we do this, because these are two different integrals. Careful. So, of course, dx. I don't understand why they don't automatically put the dx. What can it be? It cannot be anything else, but never mind. Okay, so I'm going back. So the first one was from -6 to -1. And the function was -x minus 1. The second one was from -1 to 4. And the function was -x squared, and then plus 4x plus 5. Of course, plus 5. When I hit enter, I have to get this number. If I don't get this number, then I'll have to go back to the drawing board and try again. It's okay, but I'm hoping that I don't have to do that. So it's correct. So the answer is indeed 275 divided by 6. And we applied one of the properties. of the definite integral that said that the definite integral of this function is the sum of two definite integrals. First on -6, for the first one, -6, because this is to the left of -1, smaller than -1, and this one is greater than -1, so I had to use -1 for. Very good. Back to the book. Where is it? Where am I? Here. Okay. So that's all we need to do here. We have to be careful where it needs to be split and just add them up. Okay, let's move on and look at the next type of problems. So would you like to work on any of these? Or we move on to the next set?
Can we do 13?
13, very, very good. So in 13, this is on page 425. So we're asked to find, just one second, I need to